just looking at number 7, what do you guys think? Isosceles, okay. What is the measure of RP? Okay, so 5.5 centimeters. What about PQ? 3.5 centimeters. And what about RQ? 3.5 centimeters. So what type of triangle is it? Isosceles. Okay. Number 8, what do you guys think? Just looking at it. Isosceles. Okay. SU, what is it? 3.8 centimeters. What about ST? 2 and 2/10 centimeters. And then TU, is it 2 and 2/10 centimeters? Yeah, so it's an isosceles triangle. Okay, just looking at number 9, what do you guys think? An equilateral, right? Okay, so what about VX? 4 centimeters. And then VW is 4 centimeters, right? And then XW was 4 centimeters. So it was an equilateral triangle. Okay, just looking at number 10, what do you guys think? Just looking at it, I feel like it looks like a scalene. Okay, all right, what is XZ? 2 centimeters. XY? 3 and 5/10 centimeters. And then what about ZY? 4 centimeters. Okay, so that is a scalene triangle. On your own, number 11, attention precision. The side of a skateboard ramp is the shape of a triangle. Alexa says that it is an isosceles triangle. Thomas says that it is a scalene triangle. Who is correct? So let's measure it. What is this angle right here? Use your centimeter ruler. The little bitty piece. Sorry. 1 centimeter. Okay. How about the top, the slanted part at the top? 5.5. Okay. Okay. Let's see. What about this right here, the flat part that would sit on the ground? Okay. Now, guys, are we going all the way? Sorry, I didn't even draw it all the way, but you need to go all the way to the end of the silver. Let me check. So the top is actually 6 centimeters and the bottom is 5.8 centimeters. So what type of triangle would that be? Scalene, so who's right? Huh. So just looking at it, it kind of looks like Alexa would be right, okay? Because there might be 2 sides that are equal, right? Because this might be sometimes measured. Yes, because 2/10 of a millimeter, is that very far apart? No. Okay, but can it make the difference? Yes. Okay. Right, toss them in the triangles, write the number for each triangle in the correct box. So which one of those looks like equilateral triangles? 1 and 4. And real quick, we forgot to name them. Equilateral has how many? 3 isosceles, 2 scalene, 0 equal sides. Okay, what about the isosceles triangle? 5 is 3? No. 2 is 3. And then for scalene, 5 and 6. Now, could I put 1 and 4 with an isosceles triangle? What's the definition of an isosceles triangle? It has to have at least 2 equal sides. So could I put 1 and 4? Yeah, it's kind of like the whole, a square can be a rectangle, but a rectangle can't be a square thing, right? Okay, so it could fit under isosceles, but if you wanted to be really explicit, it would only go under, those two would only go under what? Equilateral, right? Does that make sense? Okay. All right, number 13, construct arguments. Richard builds a stand to display his painting. He draws a diagonal line from point P to point R on the rectangular piece of wood so that he can cut it into two triangles. How can you classify each triangle? Okay, so without measuring, how do you know whether or not both triangles can be classified the same way? So we would have triangle. I just covered that up. What is that? O-R-P. Okay. How do you know these are going to be the same type of triangle? Because did you have a rectangle that was a perfect shape? Yeah. And you cut it in half. So if I would fold it over on this line, it's kind of like line of symmetry, right, guys? If I would fold it, or not fold it on that line, if I would cut it on that line and then put those pieces together, would they be the same size and same shape? Yeah. Okay. So both of these triangles, and then triangle RQP is what? What type of triangles are those, guys? Are they equilateral, isosceles, or scalene? Scalene, right? And then we just explained the second part.